Summer is practically here. I hope that you've had better skies the last couple of months than I have. The weather in New Jersey has just been awful, but hopefully June will bring lots of clear nights to enjoy the stars. We're going to learn about the parade of planets that can be seen in the morning skies this month, as well as exploring a large, easy to spot crater on the moon. June is looking to be a busy month for major rocket launches, so we'll touch on that and then we'll take a tour of some of the best globular clusters that can be seen on June evenings. Of course, if you're watching on YouTube, you know the routine. Please like and subscribe. We really appreciate that. And if you're listening on audio, leave us a nice review on your podcast platform. It helps us get new listeners. Please send us your questions, suggestions, comments, and reviews. You can always email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. Please check out the Astro Guy Podcast group on Facebook. The link is in the show notes. If you'd like to support the Astro Guy Podcast and YouTube channel, you can simply buy us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you. Let's get to those globulars. Welcome to the Astro Guy Podcast. I'm not an expert. I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem. Seize the night. Welcome to the Astro Guy Podcast. I'm your host, Wayne Zool. Summer is nearly here. Meteorological summer begins on June 1st, while astronomical summer begins at the solstice on June 20th. This is when the sun reaches its point furthest north on the celestial sphere. It is the longest amount of daylight for the northern hemisphere and the shortest for the southern hemisphere. After June 20th, the nights will slowly get longer until the winter solstice in December. For most of us, Mercury and Venus will be lost in the glare of the sun all month. As June begins, Mars rises just before 3:30 a.m. The red planet is glowing at magnitude 1.1 and spans about 5 arc seconds in diameter. It begins the month in Pisces and moves into Aries by the 10th. On the morning of June 2nd, the 21% illuminated waning crescent moon will be 6.5 degrees east of Mars, making for a beautiful sight. On the morning of the 3rd, the 12.5% crescent moon will be about 6 degrees west of Mars, but will be low on the horizon. Mars will get better as the year goes on, so it will be fun to watch as Mars improves as it nears opposition in January of next year. For most of June, Jupiter will be lost in the sun's glow, but by around the 3rd week of the month, if you have an excellent eastern horizon, you might be able to spot brilliant Jupiter, which will be shining at magnitude -2 and spanning nearly 35 arc seconds in diameter. As the summer goes on, Jupiter will rise earlier each day and will put on a better show as the summer goes on. Saturn is the standout as far as the planets go this month. The ring planet spends all of June in Aquarius. As the month goes on, notice how Saturn slowly moves west of Phi Aquarii. On the 1st of June, the 4th magnitude star is 1.5 degrees east of Saturn, while at the end of the month, the pair will be separated by just over 2 degrees. On the 1st, Saturn rises just before 2 a.m., so you should have ample opportunity to observe it before the sun rises. Saturn is glowing at 1st magnitude, and the disk of the planet spans 17 arc seconds, while with the rings, the system is about 40 arc seconds across. At first glance, you'll notice how the rings appear almost on edge. They will be on edge in March of 2025. By the end of June, Saturn rises just after midnight and will have brightened to magnitude 0.9. On the morning of June 27th, the 67% illuminated waning gibbous moon will be 3.5 degrees from Saturn. Visually, this should be stunning. Uranus spends June in the morning twilight glow. It is glowing faintly at magnitude 5.9 and will be difficult to spot. As summer goes on, Uranus will make a better appearance. Distant Neptune begins June about 11 degrees west of Saturn. Neptune glows faintly at magnitude 7.79 and only spans a little bit more than 2 arcseconds across. As the month goes on, Neptune will rise a little earlier each day, making it much easier to spot later in the month. In binoculars, it will appear as a faint star, while in all but long-focus telescopes, Neptune appears nearly stellar, but its pale blue color makes it stand out. On the 28th, the nearly third-quarter moon will be about half a degree south of Neptune, but due to the moon's brightness, it will be hard to spot Neptune with anything but a very long focal length scope. Before leaving the solar system, it's time for the
Lunar Feature of the Month.
Last month we explored the crater Kepler. This month we'll take a look at the nearby crater Copernicus. This nearly 58-mile wide crater is easily spotted with its bright ray complex that spans for nearly 500 miles. Named for Polish astronomer Nicholas Copernicus, who was born on February 19, 1473, and lived for 70 years until his passing. Copernicus is most famous for formulating his model of the universe, which placed the sun at the center rather than the earth. We now know that neither the sun or the earth are at the center of the universe, but during Copernicus's time, this was groundbreaking. I have plans to do an episode of The Great Astronomers about Copernicus. Stay tuned for that. Located in the eastern part of Oceanus Procellarum, the crater is nearly round and is 93 kilometers or 57.79 miles wide and 3.8 kilometers or nearly 2.5 miles deep. The crater features a terraced rim and several central peaks. The race system is a fun area to observe as there are many other interesting features nearby. As craters go, Copernicus is pretty young, at around 800 million years old. It is believed that the crater may have been created by the impact of debris from the breakup of the asteroid 495, Eulalia. The best days to observe Copernicus is when the moon is between 2 days past first quarter to 1 day after last quarter. I hope that you'll go out and try to see this crater and enjoy it for all it has to offer. There are several monumental space launches set to occur this June. The many times delayed first crewed flight of the Boeing Starliner is tentatively scheduled to lift off on June 1st at 12:25 p.m. Eastern Standard Time, in what will be the first maiden voyage of a NASA-contracted vehicle to have a female astronaut on board. Makes this not just historic, but exciting. Starliner will go to the ISS and stay there for about a week before returning to Earth and a ground landing by parachute. Good luck, Starliner. On Wednesday, June 5th, SpaceX will attempt its fourth integrated test flight of the Starship, which is the largest and most powerful rocket ever built. This will be a suborbital flight launching from Boca Chica, Texas. Starship, after separating from the booster, should achieve orbital altitude and velocity before returning to Earth. Both the booster and the Starship will, quote, land at sea, unquote, and will not be recovered. All of the Starship test flights have been very exciting, and I'm guessing that this one will be as well. On Saturday, June 8th, Virgin Galactic will launch its Spaceship Two for a suborbital flight. This will be the 7th tourism flight for Virgin Galactic. And on June 25th, SpaceX will launch the GOES-U, a weather satellite on a Falcon Heavy. In this configuration, there are 3 Falcon 9s strapped together, with a second stage on the center rocket that will put the payload into a geosynchronous orbit. Falcon Heavy launches are very exciting to watch. Seeing 2 boosters landing back at the Cape after the launch still blows my mind. Moving out of the solar system, let's explore several of the best globular clusters that can be seen on June evenings. But first, what are globular clusters anyway? Well, they are fascinating objects that offer a glimpse into the early days of our universe. These clusters are dense, spherical collections of stars, typically containing hundreds of thousands to millions of stars, all bound together by gravity. Unlike the more dispersed and younger open clusters, globular clusters are ancient, with many of them being more than 10 billion years old. These stellar groupings can be found in the halos of galaxy, including our own Milky Way, where they orbit the galactic core. The stars within a globular cluster are usually older and have a low metal content, meaning that they were formed before heavier elements were widely distributed in the universe. This low metallicity gives astronomers important clues about the early stages of star formation and the evolution of galaxies. Globular clusters are particularly notable for their densely packed stars. In the core of a globular cluster, stars can be 1,000 times closer to each other than the stars in our local neighborhood. This density creates a stunning spectacle through a telescope, where the cluster appears as a glittering ball of light with a bright core. Let's check out some of the best ones that can be observed on June evenings. We'll start in Coma Berenices with the cluster M53. This cluster, the 53rd in Messier's catalog, is also cataloged as NGC 5024. The cluster, which is comprised of nearly 500,000 stars, spans more than 110 light-years across. It's located about 58,000 light-years away from us, making it one of the furthest Milky Way globular clusters from us. The cluster glows at magnitude 7.6 and spans 13 arc-minutes in size. In my 7x50 binoculars, M53 appears as a faint, fuzzy cotton ball, about half the size of the full moon in appearance. While with my 8-inch SCT, the cluster is well resolved. This is a great object to start a night of observing with, as it's bright and easy to locate. To find M53, start at 4th magnitude diadem, known as Alpha Coma Bereniceum, and sweep 1 degree northeast, and you'll spot the cluster. To locate our next object, start at M53 and sweep almost 10 degrees north to 4th magnitude Beta Coma Bereniceum, and then sweep just shy of 7 degrees east, and you'll come to M3 and Canis Venatici. M3 shines brightly at magnitude 6.3, putting it on the edge of naked eye visibility from pristine skies. This rich globular cluster spans 18 arc-minutes wide, and is comprised of more than 500,000 stars. The cluster is about 220 light-years wide and is located almost 34,000 light-years from us. In binoculars, M3 is an easy target, even for moderately light-polluted skies. It appears as a fuzzy patch that's more concentrated toward the center, while in a telescope you'll be able to resolve dozens, if not hundreds of stars in this stunningly beautiful globular cluster. M3 is the first object that Charles Messier independently discovered. Next on our tour, we move a bit south to the constellation Serpens Caput, to the bright globular cluster M5. Glowing at magnitude 5.6, you can spot M5 with the naked eye from a dark location, where it will appear as a faint patch of light about 2/3 the size of the moon. In binoculars, M5 appears as a hazy glow that's concentrated toward the center of the cluster, while in a telescope you can resolve dozens of individual members of the cluster. Larger aperture and dark skies will help you to see even more stars within the cluster. The cluster is relatively bright at magnitude 5.6, and it spans 23 arc-minutes in size. The cluster has a radius of 80 light-years and is located about 24,500 light-years away from us. It is comprised of between 100 and 500,000 stars. Locating M5 is easy. Start at magnitude 2.2 Unuk Alhae and sweep 6 degrees west and then 4 degrees south, and you'll be looking right at the cluster. Our next object is one of the more obscure Messier globulars, but it's still a fine object to observe. M107 glows faintly at magnitude 7.8 and spans 10 arc-minutes wide. The cluster contains a little more than 100,000 stars, making for a somewhat loose globular cluster. It has a radius of 30 light-years and is located 21,000 light-years away from us. I've been able to spot M107 with 7x50 binoculars from a dark sky site, where it appears as a small patch of light, concentrated a bit towards the center. In my 8-inch Dob, it's easy to see that this is a globular cluster, but it does appear less concentrated than some of the other clusters that we're exploring this month. Locating M107 is pretty easy. Start at magnitude 2.5 Sake in Ophiuchus and sweep 2.5 degrees south, then 1 degree west, and you'll spot the cluster. Our next object is considered the best globular cluster that's visible for Northern Hemisphere observers. I'm referring to the Great Globular Cluster in Hercules, M13. The cluster was first discovered by Sir Edmund Halley in 1714 and was added to Messier's catalogue in 1764. Shining at magnitude 5.8, the cluster spans 20 arc-minutes in size. It has a radius of 84 light-years, and it is located just over 22,000 light-years from us. It contains around 300,000 stars. While not the biggest, brightest, or richest globular cluster, M13 is a standout object because it lies relatively close to us. Under dark skies, you can spot M13 as a faint, hazy patch with the naked eye. In binoculars, you can make out some of the cluster's brightest members, while in a telescope, dozens, if not hundreds of stars will be resolved. Many people see some of the stars making a fan or a propeller shape. What do you see? Finding M13 is a breeze. Locate the keystone of Hercules. Rutilicus is the magnitude 2.85 star, marking the southwestern corner of the keystone. Now imagine a line from Rutilicus to magnitude 3.45 Eta Herculi. 5 degrees from Rutilicus to Eta is where you'll find M13. After you've found it once, it will be easy to locate again and again. Moving back into Ophiuchus, we find our next two objects. Next on the list is M10. This globular shines at magnitude 6.6 and spans 20 arc-minutes in size. The cluster has a radius of 41.6 light-years and is relatively close at only 14,300 light-years away. It's made up of about 100,000 stars. In binoculars, the cluster appears as a mottled glow, while in a telescope, it appears as a very nice globular that has several bright stars that are easy to resolve. Finding M10 is easy. Start at magnitude 3.2 Yed posterior, also known as Eta Ophiuchi, and sweep 9.5 degrees east and then half a degree north, and you'll spot M10. Our next object is located 3.5 degrees northwest of M10. I'm referring to M12, which is sometimes called the gumball cluster. M12 is slightly smaller than M10, making it much easier to spot with binoculars. The cluster shines at magnitude 6.7 and spans 16 arc-minutes in size. Made up of about 70,000 stars, M12 has a radius of 37 light-years, and it is located 16,440 light-years away from us. In binoculars, M12 appears as a faint mottled glow, while in a telescope it resolves well, but visually the core doesn't seem as dense as some of the other globulars that we've explored this month. It's a beautiful cluster, and being so near to M10 is one that you should visit often. Our last object on this month's tour is back in the constellation Hercules. It is one of the most overlooked deep sky objects due to the fact that it's pretty close in the sky to M13, which outshines it. I'm referring to M92, which in my opinion is a true hidden gem. Glowing at magnitude 6.4 and spanning 14 arc-minutes in size, M92 is easy to spot with binoculars, and the view through a telescope is just amazing. Its core appears bright and concentrated, and many member stars can be resolved. M92 is 109 light-years wide and is located 26,700 light-years away from us. It is comprised of around 300,000 stars. Locating M92 is easy as well. Locate the keystone of Hercules and start at the easternmost star on the keystone, third magnitude Pi Herculi, and sweep north for 6 degrees, and you'll spot M92. I hope that you'll find time to explore these wonderful globular clusters, and that they become favorites of yours as well. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, carpe noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.